After applying the heuristics and the resource limitations to the project network, you can see the impact it has on the project network itself. We went ahead and put in the early start time, late start time, early finish time, and late finish time from the Gantt chart. And what you'll notice here is multiple critical paths pop up. Instead of having our single critical path from the initial project, the project now takes 2 days longer and the project network is more sensitive. A couple practical considerations before we show another example. Be sure that you don't change the logical constraints of the project network. It's sometimes easy to do when you're trying to schedule resources. Also notice that when you go back and look at slack, you have to look at slack from two perspectives. You got to look at time slack and you have to look at resource slack. Time slack will be very obvious because it'll be shown in the Gantt chart. Resource slack will be a little less obvious. You have to look at the resource load against the resources available to see if there's slack that now in the project that there wasn't before as a result of that. You can see the impact of that as well. Let's take a look at another example. This time we won't do it by hand. Again, I posted a couple videos that will show you the hand methods of doing it, but after the project network gets much above 6 or 7 activities, you probably want to rely on some software that's going to take care of this problem for you. And Microsoft Project can do that. I will post also some links to some examples of how this works within Microsoft Project, which you may want to try as well. So in this particular project example, this is the EMI project. In this EMI project, right now we have got a critical path that runs from architectural decisions through feature specs into the database and then eventually into review design. You can see the other tasks required. What you're seeing now are the resource loads on the particular activities. Again, each 100% is one person. So it takes 5 design engineers for the first activity, for example. Our resource requirement is 8 design engineers available on this project. So that will have an impact on what's going on here. So here's our network. Let's take a look at the Gantt chart. Again, you can see in the Gantt chart a little more detail of where the slack exists. We actually identify the free and total slack available as well on any particular part of the activities. So that's what you're going to manage around. You'll manage around the slack and see how much of that you can do within slack. If we can't do our schedule within slack, then we'll have to extend the project date to get the project done. And in fact, those are the tasks and the order in which you try things when you try this within Microsoft Project. Microsoft Project will also give you a resource usage view, so we can see how many resources we're using, the hour demands on those particular activities, and then from that you can get budget roll-ups. I think you're familiar with a lot of this. You've seen these reports now looking at the SIM project, Microsoft Project plan, but now here's another place to look at these sorts of resource utilization, resource analysis. You can tell Microsoft Project how many resources are available, and it will tell you where your overallocations exist, where they exist from each particular time period, where they exist for activities, lots of different ways to take a look at the reports. Here it's just where the resource problems are on particular activities, where they're overallocated for design engineers. You can see that we have 8 total. During that first period of time, we're overallocated by 1 engineer. At some point, we're overallocated by over double of what we need. Within Microsoft Project, if we go ahead and tell Microsoft Project what our resource limitations are, and we identified what the resource requirements are, it will tell you if we're overallocated. Then we will first tell the project software to try and reshuffle things around within Slack so that we can get the project done. It will come up with an error in this particular project saying it can't be done, and as a result of that, the project duration will have to be extended for this project to actually work. The result you can see here in the project network. We went from a 45-day project to a 57-day project. We went from having the critical path be architectural decisions, feature specs, database, review design, to now architectural decisions, internal specs, database, then review design. So you can see we had a change in the critical path. The critical path wasn't impacted by, or we didn't add any additional critical paths as a result of this scheduling problem, but we did add a significant number of days. In this case, we added 12 more days to the project. The revised Gantt chart is shown here. We can see where total slack has changed, where our activity scheduling has changed. You can see the Gantt chart looks way different than initially. And the end result of the duration of the project extended out 12 days. I think in both examples we saw the impact of resource-constrained scheduling in that we lost a lot of flexibility. We saw in many cases events becoming critical that weren't critical before. It surely makes scheduling a lot more complex, and the impact it has on the critical path that we thought we knew about has changed. Sometimes events that we thought made more sense to do sequentially get broken apart, and our parallel activities might become sequential as well as a result of the resource scheduling problem. Early on, we said we can't split tasks. We can't split tasks when we're doing this analysis. It's difficult to program tasks, splitting of tasks into project management software. It's difficult to do in general. We don't recommend it, but the reality is sometimes you need to split tasks. You just you're needed as a resource on a project, and so you got to stop what you're doing on this project to go on. And there's an impact. We split tasks up to maybe get some better utilization of our resources, but here's the reality of what happens. We're going to interrupt the work on the work we're doing. We're going to shut that work down. Then we're going to have to gear up for the next work that we're going to do, and then eventually get that work done and go back to the first task. So if it makes sense to split because the shutdown and startup costs are low, go ahead and do that. But the reality of splitting tasks and splitting people among projects and splitting their time up is the major reason why projects fail to meet schedule. Let's look at splitting activities in a graphical way. So let's say we had activity duration without splitting our activities up, and it is represented by that first white box. And within it, we decide to split the activity up into 3 segments. We'll do activity A, then we'll do activity B, then we'll do activity C, and maybe we'll be doing some other stuff in between. So we finished the first part of the activity, and we've got to shut that down. Maybe we go ahead and do something else somewhere else, be assigned another activity to do, and then we got to go back to this activity, and we'll have to start it up to do the second segment. And so you can see graphically that the activity without any splitting only took as long as what you physically see or visually see at the top, but by the time we add these shutdown and startups for the split activity, the duration of it takes that much longer. This work, I know, sounds challenging and sounds to be a pain, but there is some benefits to doing resource scheduling. We can really hammer in on our trade-offs between time and cost. We can really go back to management and say, okay, here's what the schedule looks like once we put people on it. Do we need to change our priorities? Another reason why we want to schedule resources is that we get information for the work packages, and ultimately we can actually phase the budget in. This lets us know about or plan for unforeseen events, and it also gives us some flexibility in how we're going to use our resources. Let's look at the budget part of this in more detail. If you remember our example from Chapter 4 and then again in Chapter 6, we looked at this computer prototype and we were boiling it down to the disk storage units, looking at the hard disk and looking at the tasks associated with the hard disks, looking at how the organization manages that, how it's managed within the project. Ultimately, we did work. We did $600 worth of design work, We did $650 worth of production work. We did $220 in testing work. We did some purchasing work. We did some software work, and we eventually can roll all that up to the total cost of the hard disk within the organization. You can see here that $1,660 exists within the organization, also exists within the hard disk roll-up number for that deliverable. But we can get very specific and see where the budget dollars were actually spent when we have our cost allocated properly. Looking at this example further, we can see that for the work package testing, we spent $120. We identified through this report when it was done, who did it, what weeks the dollars were required for the work to be done. So all this information is available to us, so we can actually look at our budget over time and see how it phases into the project. This report shows the software work, both programming and systems programming work for coding and integration, and again, which work periods they worked on, what dollars were deployed during what periods, and how long the duration of the work took. Let's look at an example of this in practice on phasing our budget in and taking a look at our time phase budget. So here we have a project, patient entry system. The critical path is identified and is clear. We've got these 9 tasks that will make up the project. And let's take a look and see what the time phase budget looks like for this project. What we've done here is taken the Gantt chart, and instead of putting the resources required, we put the dollars required. What we can see is for design and data, the first task, it has a $5,000 budget, and it will be done on the first day of the project. For design entry forms, it has a $4,000 budget, and we'll deploy those evenly across the 2 time periods for that activity. When we look at activity 3, it's $6,000 and happens to be distributed evenly along the 3 time periods for that particular activity. We'll also notice here that for activity 7, it's a 6-week duration, yet we're not going to spend money every week of that particular when that particular activity is ongoing. In fact, we'll spend $2,000 during the first week of that activity, no money in the second week, $4,000 in the third week, and so on. And so what you wind up creating is both your week-to-week totals of the dollars spent on the project, cumulative dollars spent on the project, and what you can create is what's called the planned value. The cumulative baseline budget is shown in the graph at the bottom of the page. Assuming you put this project into some sort of project management software, you'd see where your hours for your particular activities were. In this particular case, we've identified specific individuals and the tasks they're going to do, and we can get a report on how many hours they're scheduled to do those particular tasks. You also can get a monthly cash flow report out of Microsoft Project or other project management software to show what the dollar amounts look like month to month for the first 7 months of the project, as shown in this particular example. We've talked about this resource problem and time phase budget problem as it relates to one single project. The reality for most of us is that we're in a multi-project environment. And in a multi-project environment, we're going to have resource scheduling problems that go beyond just the one project we got involved. So within multi-project scheduling, the first problem is going to be resources. The same resources we need to work on project A might be needed for projects B, C, D, and E as well. So what happens if there's a delay in one of the projects? Well, a delay in one project might create delays for the other projects if they're using common resources, if they're using the similar equipment, if they're using the same people, whatever the case may be. In multi-project organizations, a delay on one project has its rippling effect. What happens also in multi-project organizations is that efficiency of resource scheduling, sometimes you lose that because we have resource demands that have peaks and valleys. If you think about the construction business, your resource demands in the summer are way much bigger than those during other times of the year. So we might actually wind up with extra resources that we need to have just to handle some of the peak business activities. And of course, if we've got critical activities, critical individuals, critical equipment, shortage of any of those things will cause delays and schedule extensions on projects. How do we address this multi-project scheduling problem? A lot of organizations have created project offices or project departments to oversee scheduling across the projects. Also, developing some sort of additional heuristics for putting projects at a level of priority. Maybe you use a first come, first serve for the resources. Maybe you classify your projects in certain ways that allows for resources to be taken over by one project if there's more strategic initiatives involved, for example. Maybe we centralize project management and treat all projects as part of one big mega project, as shown in the slide. And maybe we become even more creative and start looking towards things like outsourcing to reduce the number of projects we're trying to handle. So you've now just seen a few problems worked in Chapter 8, and I think you've seen the examples of where resources have impacted the slack and made the project network critical path different and ultimately more sensitive as a result of the limited resources. Again, you have to go back and look at the logic of the network and make sure you don't violate that and see what the impact is of those resource assignments in terms of free slack. You'll be amazed that occasionally slack will be hidden where you don't think it is, and other places you think you'll have slack and it really doesn't exist. So you have to be careful with that. And so what I suggest you do is try a few more problems. Watch the videos I've posted. I've posted 2 example videos by your author. And then I've also posted solutions to a couple examples. There's a couple more solutions posted in your book that you should also try, and make sure you're comfortable with this. And then eventually, let's see how the software also takes care of this same exact issue, leveling within Slack and then outside of Slack by extending project dates. So I've identified within the synchronous session specific MS Project videos for you to watch.